Take 487, rebuilding the Land Rover LT230 transfer case with the MaxiDrive 30% low range and Ashcroft ATB. I'm going through this case completely. I got it as an old case with the gear sets and whatnot. I'm putting a full rebuild kit through it, new bearings. You know, I've gone with the new bolts from Ashcroft. You know, in the master rebuild kit, you get new bearings, you get new O-rings, you get all the oil seals. You know, it's just a thorough job on the case from end to end, and obviously cleaning it as well. We've got to set up the preloads because we're using new bearings, and bearings do vary. Even if you're using the same brand and same model, they're not perfectly the same size every time. So we're going through all that, and of course we want to change the bearings in the intermediate gear set because it's an old gear set, and you know, hey, we're doing everything else, and on top of that there is a couple of marks on the bearings here that I'm not happy with and I want to change them. There's plenty out there about this with the factory stuff, but again, MaxiDrive a little bit different. There's modifications made and there's changes to the bearings and how they go together, which presents us with a bit of a challenge in how they come apart compared to the factory setup. So when you get your MaxiDrive, if you're buying new, and obviously we're talking about rebuilding an existing older set, and that's why we want to change the bearings, but I'll just go through some of the stuff here. When you get it new from MaxiDrive, you get the low range ball gear or low range output gear, big straight cut gear, and you get the modified intermediate gear cluster. Now, you either supply them your existing one, or you supply them a new one, or they can supply you a new one. It's dependent on what high range ratio you want to run. But again, if you've got a good condition used one that's your own, you can send it to them, you know, or a new one can be supplied, or they can supply it. The key thing is you cannot, and this has got nothing to do with MaxiDrive, you can't really mix and match input gears, intermediate gear clusters, and high range, low range output gears. The low range gear set factory low range didn't change much. The dog teeth changed on it, but the gear profile, the number of teeth didn't really change much. The caveat to that is there's probably small changes that are not worth risking changing it, but the low range ratio 3.32 to 1 from low to go in the LT230. That's it. They didn't offer other low ranges. They offered high ranges in, I think there was a 0.9 possibly, maybe, but there was definitely 1.003 to 1, 1.2. There was two 1.2 versions, the normal original version, and then the Q gears. 1.41 to 1, which was your standard Defender up until the TDCI, and there was an early 90 110 with a 1.667 to 1. I think that was the 4-cylinder 2-litre petrols or something. But regardless of their ratios, the gear sets are sets and they're specific to those ratios. So you can't take one intermediate gear set and mix and match it. The tooth count on the input gears vary. There's 26, there's 28, there's 32, and 32s are a different pressure angle. So this is the input gear. This diameter, the overall diameter, and the number of teeth vary depending on your final ratio, which also changes the intermediate drive gear, and then the final high range, which we'll turn that around, that's the way it goes in relation to this. The high range intermediate gear and the high range output gear, they're different depending on the specific ratio. So you can't mix and match. So if you've got the ratio that you want in your car, you can supply that to MaxiDrive, or you can start afresh with a new one, whether you want to change your ratio or not. But the point is once it's made, once it's in your transfer case, you can't say, oh look, I'm just going to change from 1.2 to 1.4 and get a new gear cluster and fit it in with your MaxiDrive. You can't do that. So that's just a little bit on the gears. They're specific to as a set. One note about input gears, apart from the tooth count, I'll just slide this over a bit more. Hopefully you can see this. The early ones were not cross-drilled, holes through here, 4 holes, the tooth length or the width of the gear was narrower. This is an early narrow one. This is 1.4 ratio, it's 26 tooth. This got wider. I'm not sure exactly when, but then they cross-drilled them about the end of the 200 TDI era. And then in 98, around 98, they moved the taper roller bearings further apart by 5mm. Essentially, they moved the rear one further rearward, and that's a benefit as well because the bearings further apart offer stiffer resistance to twisting. So the early gears you can cross-drill yourself. There's videos out there if you want to go look at that to aid in lubrication. And the reason for it is the input, the output shaft from the gearbox, which goes into the input gear, there wasn't enough lubrication for the splines, the male splines here, the female splines inside the gear, and they suffered fret and corrosion and stripped the splines out. So they cross-drilled them, they get oil lubricated, and they're essentially not a problem. So most of them you'll find are now, but again, the older ones you can drill them yourself, and some tutorials out there for it. So going back to what we receive from MaxiDrive, the modified gear set, they've lopped the low range pinion gear off, the factory one. They have machined their new one, they've broached it in with a new internal setup because the boards are different. So this is broached into the high range and the drive part of the intermediate gear set. It comes with a shaft. The shaft is custom made by them. It's different to the factory one, and it's not a modified one. It comes with their own shaft and washer and a big nylock. That's a 3/4 UNF thread that they use on here. So I'll pull this apart so we can sort of see what we're dealing with and why the bearings are different and what challenges that presents us. So regarding the shaft, I'll just pull that out. That's the shaft. So this is our low range end. This is actually a sleeve or a bush that runs on the shaft. This is the standard factory diameter through here. It runs the standard taper roller bearing on the end, on the high range end there, and it actually runs another one because you always run two taper roller bearings and you run them opposing each other. It runs another one here, so that would be there up against that shoulder when it's pulled in and secured, and then this one here is on this end and running up against the case, the wall of the case, the inside of the case with our selective sleeve that MaxiDrive preload or do the preload for us. So that ends up assembled like that, with the needle roller running on this bigger section and the two taper rollers there to control thrust, like that. So they predetermine the preload, and the reason they do that is bearings aren't perfect. They get, they have tolerances in their machining. MaxiDrive have tolerances in their machining, and they want to set preload like we do on any taper roller bearings to set that, control that thrust and put that preload on them. Because they're doing it and they're making all of this, this has to be an individual piece that's sized to this setup on every one. So they do every one. It's not just one size fits all. So your set will come assembled with that. So when you're pulling all this apart, if you are rebuilding one of these cases like I am, it's important not to lose these, and that might not just be one piece. They might have used two to get the right size. So be aware of that. Don't lose them. Be aware, slow and steady, and don't lose. Hang on to that. Again, the bearings change in size, only small amounts, and I'm not talking different brands. I'm talking exact same brand, exact same model number, come out of the same factory. There's tolerances in them, in the measurements that it's crucial to our preload. So, those two squish together, and the cups are seated at specific spots. This is the cup, the tapered cup, are set at specific spots inside that. With that set distance gives us our preload, how much resistance or frictions against those cups. if this bearing varies in height, so this is the race, and this internal part, this whole thing's a race, this internal part here is one piece through to this side. So where my fingernail is there, so if we measured from that surface to that surface, that can vary 0.01, 0.02, 0.03 or 4 even, between bearings, between one bearing, same brand, same model number. If it's bigger or smaller, that's going to change the preload. So what's important for us, like I said, strip the case down, keep this assembled, you know, keep it as that you took it out of the case. You can clean it, you can get it ready, but don't strip the bearings or anything out of it. We want to double check the preload on this in relation to everything else, because it's the last thing to go in. The preload on these, you know, Mike from Britannica Restorations has done a lot of videos, and it's really worth checking out. He goes through, you know, he's done lots of LT230s, lots and lots and lots of Land Rover videos, great resource. He's done a 9-part series about a year ago on LT230 rebuild. It's definitely worth a watch. You'll get to see all the different componentry, and he talks about assembling it and why, you know, he does things his way and how the components work and interact. So it's definitely worth a watch to get your head around that. I, like Mike, use a combination of the old original workshop manual. When I say the original one, the LT230 was originally called the LT230R, R for roller bearings. It ran needle roller bearings front and rear on the intermediate gear set with bronze thrust washers. They went to the LT230T in about 1985, and they changed to taper roller bearings, which they used then from ever to the end of the case, 2016. So yeah, taper roller bearing there and there, like we are used to on the factory setups, if you pull cases apart before and seen them. So we're only talking about the taper roller case. You can't modify the needle roller for the MaxiDrive stuff. The shaft diameter is bigger, and yeah, it doesn't work. So if you get the original LT230T manual and then the later one, there's varying ways to achieve the setups on the cases, and you can pick and choose what works for you depending on how you like to do it and what equipment you've got. Regarding the preload on these bearings, because they're two taper roller bearings there, two taper roller bearings there, and essentially two taper roller bearings there. All of those bearings have got to have preload on them to take up that slack and resist the thrust. So they're thrusting this way, because with helical gears it's always wanting to not just push apart this way, they're wanting to slide apart that way as well. So you can see this rope is attached around this gear, and that's so we can use a spring balance. And I've got just a cheap digital spring gauge or weight gauge from the auto parts store. Very simple, metric, kilograms and decimals. As soon as you load it up, it just starts telling you the weight. So, you know, very easy to use. You can use an old fishing weight like a spring balance, a mechanical one, as long as it's got the range, and the graduations are easy enough for you to read. Land Rover gives you the rates in the old manual. The newer manual uses a lot of specialised tools and dial gauges and equipment. You know, big money for the special tools. Nowhere online to duplicate or replicate them. So that's sort of like, yeah, not happening. A little bit of info about the spring balance setup that they do. When we're measuring the resistance to roll the gear. So if I turn that up again, so I've got that tight a few rounds. So we want, it's not just the initial turning of it, it's actually pulling it and making it roll, because the initial turning will be higher to get it moving. So you don't really want to see that very first reading. You want to pull it out and like a nice and long string. Get yourself a good few rotations. Don't go crazy and yank it, because you get momentum going. You just want a nice steady pull. not jerky, and hopefully you'll get some good consistent readings. And do each one a few times, pull yourself an average, and that's what you're doing. So when we're pulling on a diameter, like part of the gear or the assembly, depending on that diameter, if that diameter changes, so if we're nice and big, if we're from our center line out, which is our radius, the greater the radius, the greater the lever. It's just a lever. So a big diameter is easy to turn over than a smaller diameter for the same amount of resistance on the bearings. So it's crucial when you read the manual that you follow where they want you to run the rope. So for example, on the center diff, hopefully you can see it there, high range, low range, and this is the high-low hub. This is the selector ring, that's the hub. They want you to run the rope there, so run it there because that's the correct diameter given the range of resistance that they tell you that it can be within. The input gear, it's a little bit different because they have a tool, a special tool, which is essentially a spline like this with an end on it, and the outside end they wrap the cord around. Now, I've got no idea what the diameter is, so it's like, okay, well, how do we know? Now, granted, the drawings in the book are not fully dimensioned technical drawings. They are somewhat to scale. When you look at them, you can see that. And going by the drawings, on the end of the input gear, for a lot of the gears, there's teeth, there's dog teeth to drive a PTO. They don't have them on the disco, on certain discos, but they do have them on all the Defenders, so and Land Rover, 110s, 90s, etc. The picture shows that diameter slightly bigger on their special tool than the outside of those dog teeth. Well, so is that spot there where I've got the cord. That diameter there is slightly bigger than the dog teeth. So for me, I'm happy that it's close enough on the radius or the leverage to be reading close enough within the range. And of course, I'm going by feel as well. So the range for the input gear that Land Rover give in the old manual is from 2 kilos to 6 kilos. And when they talk range on any of these, what they say as well is the low end is for used bearings. Now, if you are reusing bearings, you're not worried about changing these. But the point is if you've got good bearings and they're used, they'll be bedded in. They're not worn, they're not like flogged out, they're just bedded in, after they've run somewhat. So they are less resistance. And that's why they'd be at the lower end of the scale or the range. And brand new bearings will be at the higher end of the range. And, so that's why they give you those tolerances. So to me, the 2 to 6 kilos, I do too. 6 is ridiculously stiff. I'd hate to run them that tight. They'd run really hot, and I'm just not a fan of that at all. The later manual gives you a way of doing it, and Mike does go over this really well. It uses a dial gauge. So you install the input gear with the bearing retaining plate. You use a thinner shim if you've got one, or a set of thin shims so you've got some sort of end float so you can feel the gear move back and forth if you move it with your hand. So you take note of the shim thickness when you install it. You have your dial gauge attached firmly somehow. It can't be independent. This can't all be moving around. And you measure how much the gear can have end float. So all the way rearward, all the way forward, and you add that to the thickness of the shim, and then you add a predetermined amount that Land Rover tell you. I think it's 0.05, so 0.05 of a millimetre. I've done it multiple times. I created a jig and everything that held everything really well. When I do it, it's really light preload. Like, I'm talking, when I check it with the gauge, the spring gauge and the rolling resistance, it's only a few hundred grams. Even taking into consideration that my radius might be a bit bigger, that's well outside Land Rover's range. So, and it just feels light. It feels light to me. So personally, I shoot for about 2 kilos. Here, it can be fiddly sometimes. This particular case, I had to use a combination of a gasket, and you do get gaskets with the Ashcroft kits. You don't have to use them. I generally don't. You just have to get your preloads right. I prefer to use, go to a sealer. But Land Rover did the same. They ended up going to sealers and discontinued using gaskets. So you know, you can, because you only have a limited range of shims, and you might have a gasket and play around with those, and you know, depending on how OCD you are, you know, so I've got that to where I want it now. So make sure you run your cords where you should, because the diameters will change things. Look at those readings, consider how new your bearings are, brand new, and go within that. And again, feel it. Don't just assume that everything's right, just go by feel as well. So we've set that preload up, That's important because A, we need to do that regardless. And what we need to do, given that we haven't pulled the bearings out of here yet, and the reason I don't want to pull them out yet, is because I want to find out the preload. Even though they use bearings, I want to find out the preload on that in relation to everything else. So I've got a starting reference. So let's say that's bang on 2 kilos. We drop this gear set in, as we would this way, with the shaft correctly installed, the predetermined spacer that MaxiDrive reviews, so everything installed as if you were doing it properly. The only difference is I use a non-nylock nut. It comes with a nylock. You can use reuse nylocks, that's fine. Some people say you can't, that's not true, you absolutely can, but I'm saying the new one till I've finally fitted it, just me. So I've just got a high tensile just a normal nut, no nylock on that. Use the retaining plate, install your shaft, plate, washer, nut, and torque it to the spec that MaxiDrive tell you, which is 85 foot-pound. So we drop that gear in, shaft, all that stuff, set it up. And what I've already got that rope pre-installed, it's just a bit easier to be able to get the rope and set up in there than it is with all that gear set. And we'll drop that gear in there, do all that stuff correctly, and then we'll take some more readings. So we already know that, let's say it's 2 kilos bang on the nose. Now we're turning that gear, the intermediate gear cluster, and the center diff with its other gears. And not only are those, there's preload on those bearings, there's preload on those bearings, there's preload on those. These gears are all driving each other as well, they're all turning, all of them at once, they always all turn. So the resistance to turn this is increased. Now, in the old book, Land Rover give you a range of how much it should increase. And the range is 1.5 kilos to 5 kilos. And what they mean is, if you've got 2 kilos here, it should increase by another 1.5 to 5. So 2 becomes 3.5 to 7 kilos. Again, I think the 7's on the high side. I personally wouldn't. But what I want to see here when I pull this with all this installed is somewhere around that 3.5. Now, remember, these bearings are old, they've bedded in, it might only be 3, but it's a starting point, it's a reference. So let's say we get our 3.5. When we go and change all these bearings and we redo it, hopefully we're at 4. Not all of a sudden at 7, because what that tells me is the bearings have changed in length enough to change the preload outside of what MaxiDrive would have set this gear set up to. So pull your case apart from the very beginning, keep all this, put it to a side, clean it, but don't disassemble it completely. Go into your rebuild, get everything to this point, front output housing, rear output housing, shafts, preloads on all that, so you're ready to put this in, cleaned and lightly lubed with the old assembly, put it in, check it again, so check this first without it, write that down, check it with it, and that's your reference to go. So that's all I'm going to go through for that part of it now. I'll do another video, a part 2 of this one, where I'll actually look at disassembling this gear cluster setup, which to my way of thinking is this cup's got to come out, this first cup, then the second taper roller bearing's got to come out. So the first cup will come out, there'll be some circlips that we can remove easily after that cup. Then this second bearing is taper rolling, the bearing, which is the race and the cup and cone, will have to come out this way. And then we can remove this circlip here and drift from this way drive that needle roller bearing out. It's the only way that can come apart. You know, we can't just get in and push and drift this stuff out because there's not enough room to get to the right part to get the straight line or access to the cup. You know, maybe a bent tool could get in there, but it would be, there's so short a distance, it would be really hard. So my thought process is, for me, I'll clean all this down, remove all the oil. I'm going to throw 3 equal welds inside this cup. That should shrink it. I've had success with this before. That'll shrink the cup. It should, if it doesn't fall out, it should just pull out with my fingers once it's cooled, because the welding will shrink the cup in. I'll do that first. Then I'll turn the gear set over. Once that cup's fallen out, I'll support it on something off the deck here. I'm going to heat this gear set with a heat gun, just an electric heat gun, no flame, nothing super hot. What I'm going to try and achieve is heating the outside so we can get this gear set to expand, and hopefully if we can get this expanding before the heat travels to the inside, which is, you know, I'm not sure it's going to work. If we can get that to expand, that center bearing assembly, which is essentially like that, race and cup all together, I'm hoping that'll fall out, because if I've got to grab this with an internal, like a blind hole bearing puller, which will go in here and then expand out on the back of it, and on the back side of here it goes in and it basically pulls out that way. Because that's a taper, to me that's a wedge, and it's going to wedge in against that and put outward pressure on the cup, and that's going to be against us trying to get it out. So I'm going to try just heating this up and seeing if we can get that cup to fall out. So it's really, to me, it's really the internal taper roller bearing that's an issue to get out. And once we've got that out, I think this is going to be easy enough. Once I've got the taper roller bearing out, I should be able to drift the needle roller bearing out. It's there. That should drift out, and we're away. And you know, I don't even know, I want to get this bearing out so I can get the part numbers off it from the bearing shop, go and get a new bearing for that. The taper rollers are you know, factory ones. I'll take them down, and when I get the new ones, I'm going to measure them with a micrometer here to check them against the old ones, to see already before I even assemble it, hey, am I going to have a difference just in the bearing heights, and take note of that as well. So that's that video for now. I think I've gone long enough, so hopefully that gives you a bit of an understanding of what's going on with these and what we've got to achieve to do a bearing swap on them. And you know, hopefully in the next video I can have some success, have a bit of a win. We can get the bearings out, and if it all works, you know, if it doesn't, I'll show you anyway and see what we're up against to change the bearings in a MaxiDrive modified LT230 intermediate gear set. So cheers guys.